Scaling. Scaling is local flaking away of the hardened concrete near the surface. The depth of scaling is usually about 1 to 8 inch, due 3 mm, although severe scaling to a depth of 3 to 4 inch, 19 millimeters, sometimes occurs. The concrete surface may look like one that has delaminated, but scaling of concrete slab is caused by freezing and thawing of the concrete, particularly when deic or salts are used, such as on bridge decks, parking lots, and sidewalks. Causes of concrete scaling: the use of non-air-entrained or less entrained air agents in concrete mix, use of inadequate amount of calcium or sodium, chloride deicing salt with lower strength concrete, using concrete with low strength or high water cementitious ratio, finishing work executed with bleed water at the top of the surface, improper finishing of concrete slab, early or accelerated drying of the exposed concrete surface, lack of inadequate curing and protection, exposure of new concrete to freezing and thawing before it has been adequately cured, exposure to aggressive corrosive salts and fertilizers, inadequate use of supplementary cementitious materials, choosing improper curing methods. The use of deicing chemicals in new concrete increases the amount of scaling. Accelerated drying of concrete. Some ways to minimize scaling include the following. 1. The use of air-entrained concrete will greatly reduce the chance of scaling caused by freezing and thawing and deicing agents. Frequent air content tests can ensure that the concrete has enough air. 2. The best defense against scaling of air-entrained exterior concrete slabs is minimal finishing. In parking garage, parking lots, and sidewalks, floating and brooming or floating only are the best finishing methods. 3. Troweling is not needed and may be harmful to scaling resistance of the surface. Troweling air-entrained concrete may also cause delamination. 4. Used wood float to avoid early sealing the surface, then magnesium float. 5. Use a proper concrete mix with durable and well-graded aggregates and a low water cementitious ratio. 6. Concrete exposed to freezing and thawing cycles must be air-entrained. 7. Do not perform any finishing operation with water present on the surface, and also initial screeding should be done followed by bullfloating. 8. Properly slope the concrete surface to drain water away from the slab. 9. Provide proper curing by using a liquid membrane, curing compound, or by covering the surface of the newly placed slab with wet burlap. 10. Apply a commercially available silane or siloxane-based breathable, penetrating concrete sealer specifically designed for concrete slabs. 11. Do not use a jitterbug or vibrating screed with high slump concrete. 12. Prevent the addition of water when concrete is troweled or floated. 13. Curing should be done properly and it should be done at least for 7 days and done according to the no of days required. 14. Provide curing using a liquid membrane compound